All right, good day. For this particular lecture video, I'll be talking about molecular geometry and polarity. Let us start with discussing or enumerating the learning objectives. Number one, determine the polarity of a bond based on the electronegativities of the atoms forming the bond. Second, determine the polarity of simple molecules and then describe the geometry of simple compounds. Let us have polarity of molecules. When we say polarity of molecule, it easily connotes or denotes the idea that covalent compounds, particularly molecule, can be polar or non-polar. Sa madaling salita po, kapag usaping molecule, ito po ay patungkol sa covalent compounds. Tayo po ay naka-focus, kumbaga, kapag molecule ay patungkol sa covalent compounds. Hindi natin pag-uusapan ng ionic compounds o metallic compounds. Kapag usaping molecule, nakafocus lang po tayo sa mga covalent compounds. Ibig sabihin, covalent compounds lamang po ang mayroong polarity. O sa usaping ito o sa kontekstong ito, ang molecule o covalent compounds ay mayroong polarity. Wherein, we also discussed polarity gives you the status wherein a molecule could be polar or non-polar. Polar meaning to say the sharing of electron of your covalent compounds are unequal polar. Non-polar molecule meaning to say the sharing of electrons of your covalent compounds are equal. Polar, unequal sharing of electrons. Non-polar, equal sharing of electrons. Polar, unequal, non-polar, equal. Now, there are two things wherein we can identify that a molecule is polar. Number one, we can determine it via electronegativity difference. Now, electronegativity difference is determined by computing or subtracting or at the same time determining the differences of the electronegativity of elements focus. Okay? Again, electronegativity difference is determined by subtracting or determining the differences between two elements that are of focus. Okay? Number two, we can identify as well the polarity of a molecule via molecular shape. Now, number two shall be our focus for this video. Okay? For this video, we are focusing on number two, identifying the polarity of a molecule via molecular shape. Molecular geometry, as defined by the PowerPoint, is a three-dimensional structure of the molecule. Okay, so molecular geometry or molecular shape is simply the 3D structure or 3D model of a molecule. Now, we can determine the molecular shape via number of bonding pair. When I say bonding pair, pairs of electrons that are bonding, as well as numbers of lone pair, meaning to say pairs of electrons that doesn't have any bonding formed within the Lewis dot structure. Now, according to definition, there are two types of shape that we need to understand. The first one is what we call the E-pair shape. Okay, E-pair shape. According to definition, E-pair shape is defined as bonding pair plus lone pair. Ulitin ko po, pag sinabing bonding pair o BP, ito po yung pares ng electron na may kabanding. Habang ang LP o lone pair, ito naman po yung pares ng electron na walang kabanding. Another type of shape that we need to discuss is molecular geometry shape. Your molecular geometry shape, we can identify the shape via E-pair number and lone pair number. Okay? Now, how can we apply the following relationship? Now, using this particular table shows you the electron pair shapes and the molecular geometry shapes. Okay? I'll be teaching how to use this particular table. All right. Now, say for example, I need to identify the electron pair shape and molecular geometry shape of the compound CH4. To draw the To draw the Lewis dot structure of methane or CH4, I will start by the central atom carbon, and then carbon has, or rather methane has 4 hydrogen. Carbon acts as the central atom, so we call carbon as the central atom. And then the hydrogen, the 4 hydrogen, we call them as terminal atoms. Ulitin po natin, ang tawag po natin sa carbon, sa Lewis dot structure na ito, ay central atom o panggitnang atom. Habang naman ang mga hydrogen ay tinatawag nating terminal atom o mga atom na nakakabit o kakabit o makikipag-bonding sa central. Central atom, pamagitnang atom. Terminal atom, mga atom na kakabit o makikipag-bonding sa central. Now to finish this image or illustration for the Lewis dot structure for CH4, we have the following. Okay, now at this point, to determine the electron pair shape of methane through this Lewis dot structure, I will start with BP. Your BP is the bonding pair. Now, how do we do that? Count the pairs of electron bonding with your carbon. So that would be 1, 2, 3, 4. So therefore, we have 4 bonding pairs. Another thing that I want everyone to understand or to have an understanding is that a single bond, a double bond, or a triple bond are all counted as one bonding pair. Meaning to say, if you see that the structure has a double bond or triple bond or even a single bond, their counting for the bonding pair will always be 1. Ulitin ko po, kung may makita kang double pair or double bond or triple bond sa mga structure or Lewis dot structure, ang bilang lang po nila kapaloob ng bonding pair ay tig-isa. Okay, so dahil meron tayong 4 na single bond, 4 na bonding pair. Next one, I shall count the lone pair, the pairs of lone pair. So you will look at the central atom. The central atom, once again, is carbon. Carbon doesn't have any lone pair. Malalaman mo po kung mayroong lone pair kung ganito po ang kanyang pagkakaguhit. Mayroong lone pair. Now we see carbon doesn't have any lone pair. Meaning to say, the 4 valence electron of carbon all have a bonding. Kung titignan po natin, 4 ang valence electron ni carbon, lahat po na 4 na valence electron ng carbon ay mayroong kabanding o kapares. Kaya mayroon tayong tinatawag na 4 bonding pair. Habang ang lone pair naman po ng ating carbon or central atom ay 0. No lone pair. Okay? Now at this point, you will add 4 and 0. 4 plus 0, you have 4. 4 would be your E-pair number. Okay? E-pair number is number 4. So go back here in the table. 4, this is your E-pair number. Look at the electron pair column. Number 4 E-pair number is directly aligning with the electron pair shape tetrahedral. So my answer for electron pair shape shall be tetrahedral. Tetrahedral. Okay, it's that easy. How about the molecular geometry? The molecular geometry is basing upon the E-pair number and the lone pair number. Look at the definition. Mol-geom is equal to E-pair number and LP number. Your E-pair number is 4 from this summation, and then your LP number is 0. So your basis would be 4 and 0. 4 and 0, look at the table. 4, E-pair number, no lone pair. They are aligned with, in the shape, according to the table, tetrahedral. So my answer for molecular geometry shall be tetrahedral as well. Okay? And that is how we identify the electron pair shape and molecular geometry shape using this table and using the following relationship for the electron pair shape and molecular geometry shape. Now let's move forward in terms of symmetry. Now what about symmetry? When we say symmetry, symmetry refers to the equal distribution of atoms. Kapag usaping symmetry po, ito po ay patungkol kung pantay ba ang distribution ng mga atoms sa isang molecule. Tignan po natin ang definition. Molecules with symmetric shapes are called nonpolar molecule. This is very profound and this is very direct. The moment we identify that a molecule is symmetry or has symmetrical shape, it is automatically nonpolar. Ulitin ko po, kapag nalaman natin na ang symmetry ng isang molecule ay symmetric, automatically nonpolar ang molecule. Okay? Halimbawa ng mga symmetrical shape ay linear, trigonal planar, tetrahedral, square planar, trigonal bipyramidal, and octahedral. Let me give you an example on how to determine symmetry. Now, since we define symmetry as the equal distribution of atoms, we can identify symmetry via a symmetry test. You do the symmetry test by drawing a broken line or a line test in the middle of the molecule. Dahil binigyan nating definition na ang symmetry ay pantay na distribution ng mga atom, tignan ang kaliwat kanan na side ng carbon dioxide. Symmetric. Bakit symmetric? Pantay o magkaitsura o kumbaga sa Ingles, mirror image ang lumalabas. We can see a mirror image for your carbon dioxide should we do the symmetry line test. So in this case, carbon dioxide is symmetrical and nonpolar molecule. Now, there are other and specific ways to identify symmetry. Let's focus here in carbon tetrachloride. Carbon tetrachloride has this structure. Now, do not be enamored by this illustration. Ang ibig sabihin lang po nito, itong linya na ito, yung parang naka-bold face na line, kumbaga ganito po yung pagkaka-drawing niya. Ibig sabihin lang po niyan na ang chlorine atom ay naka-forward. Ganyan lang ang kanyang pagkakaguhit, pero parehas lang yan ng isang simpleng single bond. Ganyan lang ang pagkakadrawing. Pinapakita lamang na naka 3D format, naka-paharap, seemingly forwarded the chlorine atom. Now what about this one, the broken line? The broken line gives you an illustration just like this one. Okay? It shows you that this particular chlorine is backward. It is placed backward. But nonetheless, this particular bonding is still a single bond. It just shows you the orientation that a particular chlorine is backward. Okay? So do not be enamored by that illustration. It's just simple. It just shows you the orientation. Now, how do I identify symmetry? We start with looking at the central atom. The central atom carbon, check if it has lone pair. Carbon doesn't have any lone pair. No lone pair. Second thing to check. Check the terminal atoms or the atoms attached to the central. Are they the same or identical? Yes. Ibig sabihin po, kapag ang central atom walang lone pair, ang mga terminal atom pare-parehas, symmetrical and polar. Let me repeat, this is all or nothing. The central atom must not have any lone pair. The terminal atoms should be the same, symmetrical, nonpolar. And let me repeat, all symmetrical molecules are nonpolar in nature. Okay, so these are the things you need to consider in identifying the symmetry and polarity of a molecule based on symmetrical shapes. What about its counterpart, a symmetric molecule? Now, in this case, this will be a total opposite. Asymmetrical molecules are automatically polar based on definition. Meaning to say, when you identify that the shape is asymmetric, your automatic answer for the polarity would be polar. Just like this one, or rather the counterpart. Symmetrical shape, no-brainer, non-polar molecule. And this time, asymmetric shape, no-brainer, polar molecule. They are always partnered with each other as descriptor. Now, examples of asymmetric shapes are your bent, trigonal pyramid, T-shape, seesaw, and square pyramidal. Let me give an example on how we may identify that a shape is asymmetric. Just like a while ago, check the central atom. The central atom, does it have any lone pair? Yes, it has lone pairs. Now, the moment that you see that the central atom, yes, have lone pair or has lone pair, your answer would be asymmetric polar. Even if that your terminal atoms are the same, it doesn't matter. This is all or nothing. If one of the two conditions are not met, lone pair and sameness or identical, being identical terminal atoms. If one of the conditions are not met, say for example in H2O, the central atom has a lone pair, this is asymmetric polar. Just like in NH3, the central atom is nitrogen, same terminal atom, but the central atom has a lone pair. So one condition is not met, this would be asymmetric polar. Okay, so meaning to say, the moment one condition is not met or not met, your answer would be asymmetric polar. Let me give you another example. Suppose that I have here a theoretical compound having a central atom A and then atoms attach theoretical element X and Y. The central atom is A, checking the lone pair. It doesn't have any lone pair. Very good. However, look at the central atom, or rather the terminal atoms. Are they the same? The central atoms are X, or rather the terminal atoms are X, X, Y, terminal. They are not the same. Meaning to say, one of the conditions are not met, or not met rather. Even though that the lone pairs are non-existent, there are no lone pairs in the central atom, but the moment that you see that the terminal atoms are not the same, your answer would be polar asymmetry. Okay, so let me repeat. For a molecule to be symmetrical nonpolar, terminal atoms should be the same, and lone pairs should be non-existent in the central atom. And then for molecules to be asymmetric polar, even if one or either of the two conditions are not met, lone pairs, there are lone pairs, terminal atoms are not the same, your answer would be polar asymmetry. Okay, so hopefully that was understood. Now, this is a short summary or conditional statements on how we can identify symmetry among molecules. You can start with this question, like say for example, does the central atom have any lone pairs? If your answer is no, it doesn't have any lone pairs, you have another question. Are the terminal atoms identical? And then so on and so forth. So let us apply this particular conditional statement. Does the central atom have any lone pairs? No, it doesn't have any lone pairs. Next question. Are the terminal atoms identical? Yes, they are all chlorine atoms. Yes, therefore, this is symmetric nonpolar. So you may use this particular conditional statements as you go along understanding the symmetry and polarity of the molecules. Now, another summary that I would like to discuss is this particular summary. Now, I would like to summarize this summary. Okay? So, once again, ito po ay, or rather, let me rephrase that. This is already a summary, but I will be giving another summary, a summary of the summary. Okay, so what the slide would like to tell us is that polar molecules can only have polar bonding. However, nonpolar molecules can have either polar bonds or nonpolar bonds. So what the slide would like to tell us is that if the whole molecule, the totality is polar, the bonding, the attraction, the single bond, double bond, triple bond are polar. Whereas a nonpolar molecule, the whole totality of the molecule is termed to be nonpolar, you can expect that the single bond, double bond, triple bond, or the attractions could be polar or nonpolar. Okay, so this is very different. When you are discussing the totality, that would be molecule. If you're just discussing the bonding or the attraction, that is your bond. So we can describe two mutually exclusive entities, molecules and bonding. Okay. Now, since I am claiming that non-polar molecules can either have polar or non-polar bonds, let us have an example, okay, if that's the case. Okay. Now, this is a particular table showing you that after computing the electronegativity difference, you may ascribe to this particular table showing you that the bond type of the covalent bonding could be nonpolar or polar or even ionic if the difference is exceeding 2. Now, in this case, I have here boron trifluoride. Now, should I compute the electronegativity difference of boron trifluoride, boron and fluorine, I have 1.94. Now, 1.94 falls under polar covalent. Okay, so I shall write boron trifluoride, it has a polar bonding. Okay, polar bonds. However, okay, let's say that the single bond, okay, the attraction, sorry about that, are termed to be polar. Okay, nalaman po natin na itong mga bonding, ayan, yung mga linya na yan, single bond. Base sa electronegativity difference ay polar covalent, papaano naman yung kabuuan, the totality rather, of the boron trifluoride? Let us check. We can identify the polarity of the polarity of the whole molecule via checking the symmetry. Okay? So let us go back to the conditional statements. Again, does the central atom have any lone pairs? Again, the question, central atom. Even if the terminal atoms have lone pairs, kahit na mayroong lone pair po yan, yung mga terminal, huwag mong pansinin yan. Focus ka lang sa central kasi yun ang tinatanong. Does the central atom have any lone pairs? No. Are the terminal atoms identical? Magkakamukha ba? Yes. Ang sagot, symmetric. At naalala natin, kapag symmetric ang hugis, ito po ay nonpolar molecule. Ibig sabihin, ang kanyang mga bonding base sa electronegativity difference ay polar bond, habang ang kabuuan ay nonpolar molecule. Okay? So hopefully that was easily understood, or I'm making a case that nonpolar molecules such as boron trifluoride can have polar bonds. Okay? So hopefully that was understood. Okay? Give me a while. Let me just configure some things. All right, so let me just reshare my slide. All right, now in this case, let me give another summary. Now, let me just read this first one. When there are no lone pairs on the central atom, then the molecule is nonpolar. Let me repeat, if there are no lone pairs in the central atom, it would be nonpolar. Now, if ever the shape would be linear or square-planar, then it is nonpolar as well. This particular rules overrule number 1. Now, the moment that the terminal atoms are different, not the same, not the identical, then the molecule is polar. This particular rule overrules 1 and 2. Now, I may understand that this is quite big or quite enamoring. So let me give another conditional statement summary. Now, this is very simple. Okay? This is just an additional statement or additional descriptor. Check again. Does the central atom have any lone pair? Boron, in this case, in boron trifluoride, doesn't have, so no. Are the terminal atoms identical? Fluorine, fluorine, fluorine. Yes, they are identical. So your answer would be symmetric, nonpolar. Okay, so you can easily identify using the symmetry, or if you identify the symmetry either symmetric or asymmetric, then you can therefore conclude polar and nonpolar as well. They are much connected. Okay, now at this point, I'll be giving examples on how to answer symmetry, polarity, and electron pair shape and molecular shape of certain compounds. So let us start with boron trifluoride. Okay. Now letter A. Let us have another example, or this is an extensive example. So this is already answered, but let me just repeat how this was answered. So letter A, check the polarity. So start with the central atom. No, it doesn't have any lone pairs. So next question. Are the terminal atoms identical? Yes, they are all identical. So I may answer this one as nonpolar molecule. And then letter B, symmetric. Okay, it's that easy. And then proceed with letter C. The next identification would be electron pair shape. We remember that the electron pair shape is bound to be solved via bonding pair and lone pair number. Okay, so I will now proceed with this particular slide. The bonding pair of my central atom is 1, 2, 3. My central atom boron doesn't have any lone pair. So my E pair number is 3. Now look at the table, number 3, electron pair shape. It has aligned in trigonal planar. So I shall write my answer as trigonal planar. Now how about letter D? Letter D would be your molecular geometry shape. The molecular geometry shape is based upon the electron pair number and LP number. You do not need to perform any mathematical operation, you just need to identify them. Your E pair number is 3, your LP number is 0. So 3, 0. Look back again in the table, 3, and then no lone pair, trigonal planar as well. Okay, so hopefully this was understood on how to identify polarity, symmetry, electron pair shape, and molecular geometry shape. So I have the same answer with that of the PowerPoint. Now, another example, okay, so that we can have more vision or understanding on how to do this. Let us start once again with the polarity and the symmetry. So once again, check the central atom. The central atom for nitrogen trifluoride is nitrogen having one lone pair. Again, this is all or nothing. The moment that you see that the central atom has a lone pair, even if the terminal atoms are the same, it doesn't matter. The moment you see a lone pair in the central atom, your answer would be polar asymmetry. Okay, just look at your questions here. Does a central atom have any lone pairs? Yes, it has a lone pair. Is the molecule linear or square planar? The shape of NF3 is not linear nor square planar, so no. Your answer is indeed asymmetric polar. Okay, very easy. A shortcut is that, just check if the central atom has a lone pair. The moment you see that there is a lone pair, even if the terminal atoms are the same or the other way around, polar asymmetry. Okay, now we proceed with the shapes. This would be letter C. We have here the electron pair shape. Your electron pair shape is characterized with BP number and LP number. So my bonding pair number is 1, 2, 3 plus lone pair. We have one lone pair. 3 plus 1, you have 4. This would be your E pair number. According to the table, E pair number is 4. Remember, that is 4 tetrahedral. So my E pair shape would be tetrahedral. Okay, so let me just move it. Tetrahedral. Now for letter D, you need to solve for molecular geometry. Now remember, molecular geometry is determined via E pair number and lone pair number. No mathematical equations needed, or rather operation. Just identify it. E pair number is 4, LP number is 1. 4, 1. Okay, so look here. 4, 1 lone pair. They are now intersecting here in trigonal pyramidal shape molecular geometry. So my answer would be trigonal pyramidal. Okay, with that said, this is your answers. Polar asymmetric, tetrahedral E-pair shape, and trigonal pyramidal molecular geometry. So hopefully that was understood. Now, to give more examples, let us have the following. So let me show more examples that may be seemingly confusing, challenging, or difficult. Ako po ay magbibigay ng mga halimbawa o paano magsagot ng mga halimbawa na parang mahirap sagutan. Okay? So I need to identify the polarity, symmetry, electron pair shape, and molecular geometry of ethane. Now from the looks of it, we always start with the central atom. Now with ethane, there seems to be no central atom. So how should we answer it? Do not fret. Remember, we identify symmetry via equal or mirror images of equal distribution of the atom or the molecule. Now, from the looks of it, if we have here a distribution check, left and right side of the ethane are equally distributed. So therefore, if they are equally distributed, we have symmetric. And then automatically, if it is symmetric, it would be non-polar. Okay? It's that easy. If you see these kinds of molecule. Now about the electron pair domain. Now you remember the electron pair domain is characterized with BP plus LP. Now in this sense, you will need to decide which will be your focus. Now since ethane has 2 possible central atoms, you may decide either the carbon number 1 or carbon number 2 should be your central atom. In this case, I will have carbon number 2 as my central atom. It doesn't it's okay to decide whether the left side or the right side to be your focus. Wala po itong kumbaga sa English ay bearing. Mamili lang po dahil alalahanin natin ito po ay magkaitsura yung kaliwat kanan. Remember, they are mirror images. So it doesn't matter if you choose the carbon 1 or carbon 2 as a central atom in checking the sheets. So in this case, I will have carbon number 2. So start with bonding pair. 1, 2, 3, 4. Lone pair, carbon number 2 doesn't have any lone pair. So 0. 4 plus 0, this would be your E-pair number. Okay? So E-pair number, just look back here in your table. 4, it coincides with tetrahedral. So your answer for this particular item would be tetrahedral. Now about the molecular geometry. Remember, your molecular geometry is based upon E-pair number and LP number. For 0, 4, no lone pair, tetrahedral. So to check my answers, I have nonpolar, symmetric, tetrahedral, tetrahedral. So that's how you answer these types of compounds. Next one. What about fluorine gas? How do we answer this? From the looks of it, once again, you do not see any central atom. So once again, you will just simply apply the line test checking. Now this is very simple. So apply this one. Then upon checking, from the looks of it, check the symmetry if they are equally distributed. Okay, so in the left and right side, as you can see, they are very identical or in mirror image. So the moment that you see they are of mirror image, you would be answering this one as symmetric. Okay, and then if they are symmetric or symmetrical, this would be non-polar. It's automatic, symmetric non-polar. On the other hand, asymmetric polar. Always remember that one. They are always partnered. Now next, electron pair domain. Now from the looks of this particular molecule, should we draw fluorine gas's 3D structure, the most appropriate, okay, the most appropriate E-pair shape, okay, and molecular geometry shape from this particular structure, the most appropriate would be linear. Linear E-pair, linear Molegeom. Because look at your fluorine, F2 gas or fluorine gas electron structure. It doesn't have any lone pair, no lone pair. And E-pair linear is also the most appropriate shape. So you would answer here as linear. Linear and then linear. Now checking, I have nonpolar, symmetric, linear, and then linear. Okay. Another example. Now this time I have here ammonia. So first thing that I need to do, check the central atom. The central atom has a lone pair. So the moment that I see that it has a lone pair, it doesn't matter if the terminal atoms are the same, this would be polar asymmetric. Remember, polarity and asymmetrical shape are partnered. So these descriptions or these descriptors are partner always. So next one, electron pair, PP plus LP. Bonding pair is 1, 2, 3, plus 1 lone pair. You have 4. Your E-pair number is 4. Therefore, 4 E-pair number, tetrahedral. Okay. How about molecular geometry? Remember, molecular geometry is based upon E-pair number and lone pair number, 4, 1. So 4, 1 lone pair, trigonal pyramidal. So, trigonal pyramidal. Okay, it's very easy. So to check, polar, asymmetric, tetrahedral, and then trigonal pyramid. Another example. Okay, so let us have here boron trichloride. Check the central atom, which is boron. Boron doesn't have any lone pairs, no lone pair. The terminal atoms are the same, chlorine, chlorine, chlorine. So this would be nonpolar, symmetric. Okay, very easy. And then check your electron pair domain, PP plus LP. So bonding pair is 1, 2, 3, and then no lone pair. So this should be 3, and then E pair number is 3. 3, E pair geometry based on the table would be trigonal planar. Trigonal planar. How about the molecular geometry? The molecular geometry, always remember, based upon E pair number and LP number. Okay, 3, 0. So 3, no lone pair, trigonal planar as well. Trigonal planar for letter D. Okay, so this is letter C and letter D. Okay, so very simple. So to check this one, nonpolar, symmetric, trigonal planar, and trigonal planar. Okay. Yes, another example. Okay, another example. Sulfur dioxide. Once again, check the central atom. The central atom has a lone pair. So the moment that you see that there is a lone pair, this would be polar asymmetric. Next, bonding pair plus lone pair. 1, 2. Remember, even if you see a double bond, their count as a pair is still 1. So you have here 2 bonding pair plus 1 lone pair. So your E pair number is 3. Okay? So 3, trigonal planar. The last one, your molecular geometry is based upon E pair number and lone pair number 3, 1, 3, 1 lone pair, bent. Bent shape. Okay? That is simply easy. So to check, polar, asymmetric, trigonal planar, and bent. Okay? Another example, let us have here chloromethane. Check the central atom, no lone pair. However, look at the terminal atoms. They are not identical. You see here, you have 1 chlorine. So the moment that you see that the terminal atoms are not the same or identical, your answer should be polar asymmetric. And then you proceed with the BP plus LP. So bonding pair of the central atom is 1, 2, 3, 4. Okay. So you have here 4. So 4 plus 0 lone pair. It doesn't have any lone pair. You have 4. So E pair number. You have here 4. So 4, that would be, according to E pair table, that is tetrahedral. Tetrahedral. So that's your letter C. Whereas for letter D, always remember this is molecular geometry. You need to base upon E pair number and LP number. So for 0, so for 0, yes, it's for 0. So for 0, no lone pair, tetrahedral. Okay, so to check if my answers are correct as well, polar, asymmetric, tetrahedral, tetrahedral. Okay, so hopefully you understood how the answers were came about. Okay, so last one, I think this is the last one. Yes, this is the last one. I shall have formaldehyde. Check the central atom. The central atom doesn't have any lone pair. However, look at the terminal atoms. They are not the same. So my answer would be polar asymmetric. So it's automatic. The moment that you see that the terminal atoms are not the same, polar asymmetric. Okay, so this is this should have two conditions met. Now, since two of the conditions, or one of the conditions rather, is not met, that is the terminal atoms being the same, polar asymmetric. And then BP plus LP, bonding pair of the central would be 1, 2, 3, plus no lone pair. Carbon has no lone pair. You have 3 as the E pair number. 3 E pair geometry, letter C, is your trigonal planar. Remember to look at the column of the electron pair. You have here outlines. Blue for electron pair and then yellow for molecular geometry to make things much specific. And then last one, letter D. So E pair number mol geom and LP number 0. Okay. So you have here 3, no lone pair, trigonal planar as well. Trigonal planar. And then once again to check, polar, asymmetric, trigonal planar, trigonal planar. Okay, so hopefully that was easily understood. Okay, so let me just configure some things again. Okay, and then once more, I'll be sharing my screen. All right. So once again, I hope the following learning objectives were realized. Okay, so let me start reading them. These are your objectives that should be realized after this session. Determine the polarity of a bond based on the electronegativities of the atoms forming the bond. Determine the polarity of simple molecules, and then describe the geometry of simple compounds. Okay, so I hope the following learning objectives were met, and I hope as well that you learned a thing or two in this lecture video about molecular geometry and polarity. Thank you.